Okay. Welcome everyone for this live session of Aspen Plus Simulation Software, a basic course for beginners. And here through the Microsoft Teams, I find only a couple of participants, Ashish Sharma and Rajesh Bhatkar. Welcome to you both. I do not know whether others will join through this channel. And in YouTube, I do not find anyone joining. I hope people will join very soon. Unfortunately, I'm not able to see anything in the YouTube channel. NPTEL office, is there any problem over there? In the YouTube channel, nothing is coming. Yes, NPTEL. Yeah, in YouTube channel, nothing is coming. I do not know. I'm not able to see anything. You are not able to download Aspen. Setup file is not opening. Snehal, I do not know. It is already past middle of the session, so I mean, I do not know whether you are facing this download problem of Aspen from beginning, or you are in the middle of the course and somehow you have lost the link or something. Because if you have not done the course till now, then there is no point in, you know, doing this course in the middle. Anyway, I suggest you to write an email to this link. See this particular email address. You write to me, I will help you out. Okay? And this is for all the learners. Whenever you have any problem regarding this course, please write an email to this email address. Yes, Rajesh Bhatkar, are you trying to say anything?
I want to say thanks to you, sir, for all the efforts to you and the NPTEL team for the efforts and your total guidance for this course. But what we find that where there are a lot of obstacles are there. So is there any tutorial available where the more examples for stepwise procedure is available?
Thank you, Mr. Bhatkar. I believe you are enjoying the course, so thanks for your endearing words. But I'm not sure what type of steps you are referring to, because as far as the steps or details of the course is concerned, I think I have covered everything. Now, if you want to get more examples, then obviously internet is, a sea of opportunity. So you can search for examples everywhere, and you can get them. There might be certain repetitive examples also. Yeah, I mean, there is, and also Aspen Plus has various forums, you'll find those forums, and they sometimes discuss with certain problems they face, and they ask questions, and someone else in that same forum, they answer these questions if they are able to. So it's a kind of forum for exchange of information, and there also you will get some real life examples where you can learn. But only bottleneck is if you do not possess the software by yourself, then it will be difficult for you to continue your studies after this session is over, because after the exam, this particular site will not be open for you. You can no longer access Aspen Plus license. Okay, so that's the only issue. But yes, you can get a lot of examples everywhere, and there are no such universal steps. I mean, each and every equipment that I have discussed, like separator or reactor or the columns, they have different parameters to be set, and you need a protocol for each and every equipment separately. The overall step obviously is first set the property method, and then estimate the properties of each and every component that you want to work with, set the reactions if there are any, and then go to the simulation block and bring in all the equipment one by one from the model palette, connect them, etc., etc. So that was the overall procedure and steps. Other than that, I do not know what you are referring to. And I find another member over here. It is Gaud underscore 20845. So welcome, Gaud. And Ashish Sharma wants to ask some question. Okay, carry on, Ashish. Ask the question, whatever you have.
Good afternoon, sir. Actually,
Yeah, good.
in lesson number 24, production of methanol from syngas, I am getting a error message on the reactions, and I also wrote down that error message in the Google form, which was provided for this meeting. So, if you allow me, then I can share my screen and show me the message, but I'm getting the error.
Okay, please do it.
Okay, sir, I'm sharing my screen now.
NPTEL, I am yet to see anything in the YouTube. I do not know whether you are working on it, but I don't find anything in the live session.
Sir, can you see my screen?
Yes, I see only the Microsoft Teams. You just have to, yeah.
Yes, sir. This is the Aspen Plus window. So
Right.
here in the reactions, when I took compute K equivalent from Gibbs energies, then there is no error message. Okay, sir. And the stream results, and I can show you. We have a very low production of methanol here. So after that, when I'm giving this compute K equilibrium from built-in expression, when I take this for all the reactions, then after running the simulation, sir, I am getting this kind of error message. So in the run test, it is not showing, but here in the block of reactor, in the results status, I'm getting this error.
Okay.
Material balance loop did not converge in 50 iterations. Check stoichiometry and molecular weights.
Okay. Unfortunately, I have forgotten what I taught in particularly lecture 24. So I have to refer that first before I can. But about the reactions, just go back to your reaction.
Yes, sir.
Yeah. And go to the equilibrium and yeah, those values of A and B, from where did you get?
Sir, in the lecture number 24, where you taught that lesson, then
Okay.
the exact value you put on your simulation, that these are the exact value. I followed everything in that video, but in that lesson, there was no error. But when I perform the simulation, I'm getting this kind of error.
Okay, okay. Did I take K equivalent on fugacity basis?
Yes, sir. When you took from this compute K equivalent from Gibbs energies, then there the methanol production was very less. So you told that as much as information as possible you give to Aspen, then it will perform better. So after that, you computed all the things from built-in expression, and after getting these values, and your simulation was run perfectly, but here I am getting some errors, and most of the learners getting many errors. In the discussion forum, I can see that many of the people getting this same kind of error.
Okay. Then I have not visited discussion forum for a long time, so I am not aware of it. So can you please share this file with me so that I can, until unless I check the file myself.
Okay, sir. Sir, I have not performed the complete simulation because I'm getting error in the reactor, so I did not move forward to the complete video.
No problem. No problem. You just share this 24.apwj file.
Yes, sir.
Then I can, because did you take the property method correctly? Whatever I have suggested.
Yes, sir. In that video, whatever procedure you have told, I followed that procedure. So in that video, you suggested PSRK method. I chose PSRK method and just run that simulation and properties environment. And after getting into the simulation environment,
You go to the property environment once. Go to the property environment.
Okay, sir.
And you run it.
Okay. Yes, sir. Results are available.
Okay. Okay. Because initially I found something wrong in the results, so I was a bit worried. Anyway, fair enough. You can just share this file with me. I will check myself and I will try to
Okay, sir, sure. Sir,
Email
how
this.
can I share this file to you?
Email. Write an email.
Okay, sir.
Okay. Write an email
Okay, sir.
to.
So now, sir,
Yeah.
please provide your email address.
It is p.shah and okay, I'll write it over here.
Yes, sir.
Where is the chat session? Yeah. It is p.sah@iitg.ac.in. Okay.
Okay, thank you, sir.
Yeah, Rajesh Bhatkar is saying, can you please add mobile number, this thing, discussion forum. Which discussion forum, Rajesh, you are talking about?
Yeah, just now it was mentioned that we are part of some other discussion forum. So
No. What I said, there are a lot of discussion forums of Aspen Plus.
okay.
So you can be a part of that. I mean, uh, do not think that I am the part of OS and they will give you an email address and password and then you can join them. So I have given you some information how to do it, but then you have to look for those
Yeah.
discussion
Okay.
forums yourself.
Thank you, sir. Actually,
Okay.
one suggestion, if it is possible, we are all learning under
Yeah.
this guidance. This is very useful course what you are conducting. Can we also form one this WhatsApp group? So where we can share this practical
Uh,
problem.
I am not sure about the WhatsApp group because WhatsApp groups are, I mean, lot of junk messages will also come. Somebody will send some
Yeah.
good
This
morning
dedicated for
message, night message, and all.
Aspen Plus learners. Yeah.
Right. Your idea is well taken, but then, uh, I mean, there are huge number of learners. I mean, if the correct number is, I think this semester, every semester, nearly 2,000, 2,500, over 3,000 people, they join in this course. So a WhatsApp group of 3,000 people will be too much. So it's not a small group, and
Okay.
obviously, as far as NPTEL is concerned, they will not officially endorse any WhatsApp group, I am sure, because it is not within their take. But you learners, I mean, amongst you,
Yeah.
if you want to do something like that um, after discussion among yourself, then it is unofficially you can do it. I mean,
Okay, sir. Thank you, sir. Thank you.
okay. And I find two more participants over here, another and Sarwar Hossain, Ashin Kumar and Pranav Shinde. Yes, Pranav Shinde, I find you have sent one message in the Google Sheet. You have a problem with the lecture 25, lecture 24, synthesis of methanol. So just now I was discussing with another participant, and he also has the same problem. So I have asked him to share uh, his .bkp file or .apwj file, whatever he has. So you also can do the same thing. You can send me that particular file, and I can see what mistakes you might be doing. Okay, that way, Pranav, I can answer your question. And another person, AK, I think Ashin Kumar, yeah. Ashin Kumar is concerned about week 7 answers. I don't know what he means by that, but some other person like Edwin Varghese Thomas, I don't know whether the person is here, says that kindly help to solve the assignment 7 as it was harder to solve. Well, for getting the assignment 7, I mean, I will not be able to put it in the forum. You can write an email personally. I can share it with you. Okay. So I guess there is no error as such. It's a week 7 problem. Yeah, how to solve week 7 question? I do not know whether is it already evaluated, because if it is not evaluated, I cannot give the solution. Okay. Ajmira Subbarao, I do not know whether he is here. He is not registered for certification exam because of, then he has to come the next session, January session. Many people are facing license problem. You can write to me directly. I will forward your request to someone else. Sanath H. Menon, is saying the range of answers in the solution key is too low. My model answers range in answer in bracket. Solution key is too low. Is it? Okay, I do not know whether you have sent me. Somebody sent me one this morning only. I have received an email. So I don't know whether it's the same person. I promised him to help out with that question. Okay, many people have problem with the assignment part B. Okay. Now if I okay, we'll try. Let me see what is the assignment 7. Why people are facing so much of a problem. Yes, Ashish Sharma, I have got your email. An equimolar binary mixture of N-heptane and toluene with flow rate of this much is separated by extractive distillation at atmospheric pressure using N-methanol, NNP, right? Column. Well, it's a long problem. I mean, if I start solving it online, then it will take a lot of time. It's already 3:26. I'll not be able to take others' answers. Yeah, Rajesh Bhatkar.
Sir, actually in this problem,
Yeah.
this N10 trillion, the problem is when we select NRTL and estimate binary interaction parameters, then
Yes.
also this azeotrope is not predicted. It is showing simple system with NRTL. The property method suggested is NRTL, and to estimate binary interaction parameters with UniFact. So in ternary LLE data also from NIST had done a regression, but then also there is no prediction of azeotrope. So since that basic step is missing, I think that is the problem. I also could not proceed on that. So I don't know where what step we have missed and what is a mistake. Is it clear, sir?
Okay, can you share, I mean, if you have Aspen Plus with you, can you share it? I mean, can you share it on the screen? Because I do not have that file with me, then if I have to start, it will take a long time.
Unfortunately, I don't have in this system.
Oh, okay.
So problem is when we enter the component and go to the property method, we go to NRTL, and for NRTL, then we go to the binary interaction parameter. There we select NRTL and estimate parameters using UniFact. That we complete. And after that, when we go to the analysis ternary data, then using that Aspen distillation tool, we cannot estimate ternary system. The example what you have shown was the other ternary system, I think acetone water or some different system. There we could see all the azeotropes in that system by the same procedure. So here I think that thermodynamics, that was the problem there.
Okay, so let us do one thing. Let us try to do at least the property
Yes, yes,
analysis. Okay, so that will be short. I don't think it will take much time. So we have N-heptane and toluene, right? So we'll write heptane toluene
and NMP. If we type NMP, yeah.
NMP, will it come?
Yeah.
Oh, great. So these three things, right?
Yeah.
Okay. So, yeah. So we have to use NRTL property method and estimate missing binary interaction parameters using UniFact. Right. So let us go to NRTL. Next, estimate using UniFact. Next, yeah, now tell me what problem do you face over here?
Yeah, when we go to analysis and in analysis drop down list we select on the top here, ternary.
Okay.
Yeah, drop down list, sir.
Yeah, I find this one.
No,
so you do not need that.
Yeah, in this menu bar analysis drop down list.
Yeah, you have to find the azeotropes, right?
Yeah, find the azeotrope. So when we go to analysis and that ternary diagram, yes, sir. Yeah. So if we click on azeotropes here on the left hand side, in the output second point, we select all the component and check the output. If we click on azeotropes,
Right.
yeah, here, yeah.
Okay,
Actually, the
okay.
message is popped up. No azeotropes are formed.
Okay.
Whereas I think between the toluene and NF10, that 25-75% is a azeotrope composition. For this system, only the information displayed is the pure component boiling points only. In report also, the azeotrope properties are not estimated. I got the message that no azeotropes are formed. So I used in NIST data VLE also, but that VLE data are also not showing azeotrope formation. So
Okay,
there is
so
in
your
ternary
point
data,
is
LL
that
is there. Yeah, in ternary data, sir, LL is there, but I don't know how to regress this combination of VLE and LLE data.
right. So in this situation, as you feel that probably azeotropic distillation is not possible. Okay.
Yes, sir.
So it is measured at 1 atmosphere. Okay, so probably this might be the problem. Atmospheric pressure. Okay, I'll do one thing. I will continue with this simulation later and I will check. And if that is true, then probably we have to do something with this part B. Okay, fine. I will check this. Okay.
Thank you.
Okay. Yeah, Jyoti Kadamasu is asking, sir, if you can cover these topics, elect wizard and creating a scenario table using Aspen simulation workbook. Elect wizard, I mean, you want a simulation of, okay, I can show you something, although I'm not sure whether I'm permitted to show because I have done it for some other person. Okay, first let me stop sharing this. I'll open the file and then I'll share it. Okay, so here some elec wizard you will find. I will explain this thing very short note. Here we have a process plant where it is used for CO2 sequestration. So we are having a raw feed, and that raw feed contains 1000 kg per second of gas at 94 degrees centigrade, 1 atmosphere pressure, and its standard volume fraction is only 4.5 volume fraction is CO2, 9.4% water, and mostly nitrogen and oxygen and little argon. So this is our raw feed. Now we have to separate this CO2. Okay. So what we are doing, we are sending some lean amine, and here amine is 0.3. So it is like 30% amine, and 70% water. That is coming in the lean amine. So lean amine is poured from the top, and raw feed containing CO2, it is sent from the bottom, and they are getting absorbed. I mean, CO2 is getting absorbed in amine, and that absorbed CO2, it is rich amine. That means amine along with the absorbed CO2, it is stripped in the stripper. CO2 is coming out. Amine is getting lean. It is fed back and recycled in the lean amine stream. In the gas out, mainly oxygen and nitrogen go out, and very little amount of CO2. And here it is a partial condenser in the stripper. So we get partial, we get mostly CO2 over here. and this line contains mainly water. This is the makeup amine line, this is makeup water line. And there are 3 or 4 um, heaters or coolers rather. So they exchange heat between them. So you can see the carbon dioxide kg per second. We have 69.69 kg of carbon dioxide per second. It is going in through the raw feed, out of which 66.19 kg per second we are able to recover. Okay, so our system has been optimized to 95% of CO2 recovery. Okay, so this is a part of consultancy project that I have done. So I wanted to show you. Unfortunately, I cannot give you any details regarding that, or I cannot share this file with you. Here you can find this charge balance. Why this charge balance is there? Because here we are handling in the property, you can see we are handling ions. In the stoichiometry, we are handling ions. H3O plus, HCO3 minus, CO3 minus minus, OH minus. We are using methyl ethylamine. So this ion, okay. So these are the chemistry that we are putting in. And you can check in the component specification, we have this monoethanolamine, argon, nitrogen, oxygen, carbon dioxide, water, and all of these are ions. And for that, you need to use elec-NRTL method. Okay, so this is electrolyte NRTL model with Redlich-Kwong equation of state for aqueous and mixed solvent application. So whenever you have such electrolyte present in your system, you have to use them. And they have certain electrolyte wizard you can use. And so unfortunately about this particular system I cannot discuss anything more. Then probably I will violate some copyright. I wanted to show this because this is how the electrolyte systems are handled. Okay. So Jyoti Kotamasu, I believe I have answered your question. And then same issue I have faced. Yeah, Chaitanya Ram Varsale, week 7 assignment question, there might be some problem. So I have to revisit this Lokesh Acharya is asking, sir, in assignment, which assignment? Is it assignment 7? In assignment 7, I don't think ethanol is there. Oh, assignment 8, okay. So you are asked to find mole percent of ethanol conversion in feed stream. Mole percent of ethanol is 0.5, and in sensitivity analysis I find ethanol in product stream this. So mole percent conversion of ethanol should be difference between mole percent of ethanol in feed and product stream. I didn't understand this particular question that you are asking. I mean, do you claim that answer in assignment 8 is wrong, or if it is something like that, please write an email. I mean, it's a kind request to each and everyone. Please write an email to this particular email address that I am writing over here. Okay, I mean, because if you ask me on the live discussion and all, it is not possible for me to answer them. The assignments are made long back, and some of the things I have forgotten also, so I just do not recollect what you are saying. So if you send me your issue through email, then I can revisit the assignment and then I can answer your question. So please send me email. Okay, Lokesh Acharya, no sir, I am just asking that is percent conversion difference in feed and product, or it is just result of product stream? Okay, let me go to the assignment then, and which question it is, Lokesh? Mole percent of ethanol conversion for a reactor volume of 0.5 and 4 meter cube are this and this respectively. Yeah, actually, whatever is coming in the feed and whatever is going into the, I mean, whatever is the product, so it is about how much ethanol is produced per unit of feed, right? That's how it is. Yes, local. Did I answer your question? And at the end, you will find whatever mole remains. So that is the percent mole conversion. I mean, I think a question is straightforward. Yeah, Ashish Sharma, sir, can you please start a course on Aspen High Sys as well? It will be extremely beneficial for us. I do have plan, but it is very, very tiring to design a course like that. I am already in the process of designing a course for Aspen Plus, uh, advanced course in Aspen Plus, but I have prepared only 5 hours of lecture till now. Another 25 hours lecture I have to prepare, and it is quite time taking. So your suggestion is well taken, but it will take time. Definitely, it will take time. It will not be done it will not be done very soon. First, I will finish the Aspen Plus Advanced, and then probably I can take up that project. So in the YouTube, I do not know. Yeah, YouTube. So whoever has asked some question today, I believe the assignment 7 is the real problem. So I assure you that I will revisit the assignment 7, and then whatever the associated issue, I will try to address it properly. Okay. Akshay Kumar Das is saying, sir, do you work in, what's that? Parvo. Is it Parvo cut? Something is hidden over there. Some photovoltaic cell, solar cell. No, I never worked in solar cell. Sorry. I never worked in solar cell. Yeah, Shiva Singh, assignment 7 was very tough. I'll address this issue definitely. Okay, any more questions? We have 5 minutes left. So if you do not have any more question, then perhaps we can wind up this session. Okay, so thank you very much.
Thank you very much, sir, to you and the NPTEL team. Thank you very much.
Okay, great. So NPTEL, can you please wind up the session?